Hi everyone, I'm Won-Lee. Today, interaction effect will be explained. We saw interaction effect on the model two-way ANOVA with replications. When you have multiple observations for each treatment, you may get interaction effect. So the thing is there interaction effect or not? But what is interaction effect? Interaction effect in two-way ANOVA with replications, we can examine the interaction between factor A and the factor B. If the effect of factor A on outcomes of observation differs across different levels of factor B, then two factors A and B are said to interact each other, something like that. For example, it is believed that test score Y depend on study time, factor A, and sleep time, factor B. So a two-way ANOVA with replications was decided upon. Okay, let's apply two-way ANOVA with application model. Suppose study time A is divided into 5 hours and 7 hours, and sleep time B is divided into 6 hours and 8 hours, creating four treatment, right? And each combination is assigned five students for testing. Here, it is necessary to assume that the person tested are under the same conditions. It is pretty hard assumption anyway, right? The same condition. Let's consider scenario where the averages of scores, five student scores average obtained from five individuals are as follows in the table, like this. 5 hour study and 6 hour sleep, 130, the mean of five students. 5 hour study, 8 hour sleep, 140. That is 140. This is 130. This is, say, score. Okay, 7 hour study, 6 hour sleep, 160. 7 hour study, 6 hour sleep is 160 here. Okay. Okay, and 7 hour study, 8 hour sleep, 170. 170. It is some extreme case, but it is the lines are parallel. So no interaction. Okay. This case, another example, 5 hour study, 6 hour sleep, 130 here, 130. And 7 hour study, 7 hour study, here 5 hour study, 7 hour study, 6 hour sleep, 160 here, 160. Okay. And 5 hour study, 8 hour sleep is 120. 8 hour, 5 hour study, 8 hour sleep, 120 here, 8 hours. And 7 hour study, 8 hour sleep, this case is 170. 170. That maybe happen like this case or this case. Okay. Then the line is closed here. So it is interaction effect is very strong here. Interaction. Here, no interaction. So how much parallel is dependent upon uh, the key, like this. Not this case is a perfect parallel, but it is not perfect parallel. So depends upon the slope of two lines decides there is interaction effect or not. Okay, let's see simple example. Advertising effectiveness score Y. Advertising effectiveness score is sometimes necessary for measuring the effect of TV advertising is measured as the total score of 10 variables. There are 10 variables, and they score for each variables, and they measure the effectiveness score. Okay, it is assumed that advertising effectiveness will differ depending upon the type of a program, ABC, show or entertainment or news, something like that, and the frequency of exposure to the 20-second advertisement. That means number of changing exposure. Okay, that is exposure frequency 10 times or 15 times. For children, the number of changing exposure is big, large. For older person, aged person, slow change of exposures. Okay, so two-way ANOVA with replication is performed. Total of 12 potential consumers were selected and assigned to each of 6 treatment. They are 6 treatment, 2 by 3, so 2 persons assigned. And here 47, 43, 46, 40, something like that. Following 3 hypotheses can be tested. There is no interaction effect. No interaction effect, or there is interaction effect between 2 factors, a programs and frequency of exposure. Okay, that is coming up here. The result is here. So say p-value is 1.3746, very big p-value. So there is no interaction effect, you concluded. And for advertising effectiveness based on frequency of exposure, that is this one. So p-value will be 0.3226. Okay, there is no difference. I mean, exposure treatment effect, no difference. Okay, and there is no different advertisement effectiveness based on type of program. ABC type of program, p-value is 1.00058. So very small p-value. There is, some difference, strong difference between program ABC. Then we like to know which program has some different effect to others. Okay, A is very different from B and C, or AB are different from C, something like that. That is called multiple comparison or range test. I'm going to explain that kind of a thing. It is a little, some complicated topic, but I'm going to explain that kind of a thing later this lecture. Okay? Okay, that's it today. Thank you. Bye.